Now, when the students compare fractions, they are not allowed. Remember, these are pre-service teachers, right? So students, you are not allowed to find common denominators, because even though you know how to do that, the third or fourth graders may not know how to do that yet. So we're going to try to get a conceptual understanding of these fractions, and we're going to try to see which fraction is larger and why. And so we're going to use a couple of reasons. We're going to use either knowing about the size of the denominator, the size of the numerator, or comparing using some type of model. So for instance, let's look at 7/12 or 5/12. Which fraction is larger? So the rationale is the denominator tells you the size of the fractions. In this case, both fractions are twelfths. So over here I have 7/12, 7 apples, and over here I only have 5/12. So right away I know 7/12 is larger, because if they're the same size pieces, and I have more because the numerator tells you how many pieces. So I have 7 of those 12s here, and I have 5 of those 12s there. So I will circle that and say this 7/12 is larger. So that's one of the rationales, looking at the size of the denominators. Now let's look at another rationale. Here we can see that I told you that the numerator says the number of pieces. So in both cases I have 3 pieces. So now I have to rely on the size of the pieces, because if I have 3 pieces over here and 3 pieces over here, I have to see which size pieces are bigger. Well, let's see. I know that sevenths is smaller than fifths. Fifths is larger than sevenths. How do I know that? Because if I have a pizza pie and I cut it into 5 pieces, the pieces will be larger than if I had a pizza pie and cut it into 7 pieces. 7 pieces, I have more pieces, but each piece is smaller. And of course you can use your grid paper. I didn't talk about grid paper, but you can use your grid paper, and you can use your fraction strips, and you can use your circle fractions to see which one is larger. So in this case, this is the rationale. I have 3 of each piece, but the fifths are bigger pieces, so the 3/5 is larger. Now the last one is a little more difficult, okay? So the last one is this. I'm using fraction strips here. So here, can you tell me which of the denominators gives me a smaller size piece? Do you think ninths are smaller pieces than eighths? Or do you think eighths are smaller pieces? Which is the smaller piece and which is the larger piece? Let's see. I say 9 is the smaller piece because I have more pieces of the same whole. I have more pieces, so the pieces get smaller as I make more pieces. Okay? Now look at this. This is interesting. 8/9. Well, 8 is only 1 piece away from being a whole. 8/9. If I had 9/9, I would have a whole. So I only have 1 piece missing. Let's look at this one. 7/8. 7/8 means I'm only 1 piece away from having a whole. 7/8, the whole would be 8/8. So if I only have 1 piece missing here and 1 piece missing here, this one has a smaller size piece missing. So the 8/9 will take up more space than the 7/8. And then you're going to have to try that. Okay, let's look at the fraction strips. You can do it with a pizza, but I'm going to do it with fraction strips. So for the fraction strips, I have to start with the same size whole. So if you see my fraction strips, they go straight up. It's the same size whole. So the length is the same. But in order to get ninths, I could not draw right on the line like I did with eighths. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So each time I count that, I have 8s. Okay? Oh, so I have the wrong thing here. But let's just keep going. So I have 1, 2, no I don't. 1, 2, 3, 4, 5, 6, 7, 8. Oh yes, I have 8s. So I can shade in 7 8s. Okay? And so if I shade in 7 8s, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s. There's my 7 8s. Now for 9ths, I don't know, you can't see it there, but I couldn't draw right on the line, because if I drew right on the line, I would only get 8 pieces. I want 9 pieces. So I had to draw them a little smaller. But if I'm going to use a different color. If I color in 9ths, and I color in 8 9ths, that last piece that's not colored in is a smaller piece. See, this piece is a little smaller than the 8th. The 9th is a little smaller than the 8th. So therefore, the colored part, the yellow part, is actually more than the 7 8ths. So the 8 9ths is larger than the 7 8ths. So the larger fraction is 8 9ths. They just happen to all be first. Let's see, what else? I drew a number line. And the reason I drew a number line is if we were looking at some fractions and I wanted to compare the fractions, I could do something like this. Let's see. Let's try 3/5 and 4/7. Okay? And one of the ways I can compare those fractions is to look at the number line. And so when I look at the number line, I use something called benchmarks. Parents, benchmarks means I know benchmarks. My benchmarks that I wrote was 0, 1, half, and 1. Because many students will know if a number is really small. If I say 1/10, for say, they're going to know that that number is way down here near 0. It's kind of small. If I say 1/100th, it's really small. It's even closer to 0, right? If I say 1/1000th, it's even smaller. So some numbers are closer to 0 than others, some fractions. Whereas some fractions are close to 1/2. Most students know 1/2. They know 4 is half of 8. They know 10 is half of 20. They know 50 is half of 100. So if I have 51/100, then they know that's close to a half. If I have 5 8s, it's kind of close to a half because 4 8s is a half. Okay, so let's look at the numbers, the fractions that we do have. So 3/5, oh, you know what? I'm going to write 2/5 because I'm trying to make a point here. Okay, so if a student saw 2/5, they would say, oh, 2/5 is a little less than a half. Because I know half of 5 is 2.5. So 2/5 is a little less than a half, but 4/7 is a little more than a half. So 2/5 would be on this side of a half, and 4/7 would be on that side of a half. So you have 2/5 is a little less than a half, 4/7 is a little more than a half, so 4/7 is my larger fraction. All right?